Hi everyone, so today we're going to talk about equivalency tables, and you should have the foldable for this lesson tucked into your notebook. However, if we have any issues with that, I will attach it to the calendar as well. So first you're going to go through and write down your learning goal, and today's goal says to make tables of equivalent ratios relating quantities with whole number measurements, find missing values in tables, and plot the pairs of values on a coordinate plane. You're also going to use the tables to compare ratios. So at the very top of your page, you should have the first set of data, and it says the table and graph below show Lacey's pay for different number of hours. Complete the table and the graph. For every 1 hour Lacey works, she makes $15. Well, first of all, I want to make sure that I'm ready to go in terms of my table. So the statement says for every 1 hour Lacey works, she makes $15. So if she worked 1 hour, she makes $15. If Lacey worked 2 hours, I can think of her pay as being twice as much as if she worked 1 hour. So twice as much as 15 is $30. If Lacey worked 3 hours, she gets paid 3 times $15 an hour, which would be a total of $45. If she works 4 hours, I can add $15 to her previous pay for working $3, which would be $60. And then for working 5 hours, she's going to make $75. The ratio of pay to hours is comparing the amount of pay she gets to the number of hours she works. So it's kind of the reverse of our table. Remember, you can always simplify ratios just like you can fractions, so you may want to look and make sure that this is a constant ratio, right? When I'm comparing 15 to 1, 30 to 2, 45 to 3, all those ratios can be simplified to be the same amount, which is 15 to 1. It also asks us to fill in the graph. So I want to make sure that for every 1 hour Lacey works, I'm reflecting that she gets paid $15. So at 1 hour, she gets paid $15. At 2 hours, she gets paid $30. At 3 hours, she gets paid $45. And I can go on like that. I can also think that at 0 hours, if Lacey doesn't work at all, she's not going to get paid, right? So I have to make sure that I plot that point. And eventually you should have this straight line, which is going to represent that the ratios are constant, that this is a pay per hour, right? The second example we have is about the school dance and having punch at the school dance. So it says the 7th grade student council is putting on a school-wide dance. The students have to make punch for the kids at the dance. They estimate 240 students will come. The punch is made up of 3 ingredients: orange juice, soda, and pineapple juice. There are 2 recipes for the juice. Both make 10 cups of punch. So the fact that they both make the same amount of juice is important for us to think about. It says the student council is not sure which recipe to choose, so they decided to compare the recipe amounts for 240 cups of punch. Compute the table. So we're going to go through and we're going to look at recipe number 1, and we're going to compare it to recipe number 2 in terms of how much of each ingredient we need to make a certain amount of recipes. So first it just asks you for 10 cups. Well, both recipes already make 10 cups, so I'm just going to copy them as they are. Recipe number 1 has 5 cups of orange juice, 3 cups of soda, and 2 cups of pineapple juice. Or recipe number 2 has 4 cups of orange juice, 2 cups of soda, and 4 cups of pineapple juice. So now, if I want to figure out how much of each ingredient are in 100 cups of the recipe, I'm going to go from the 10 cups to the 100 cups by multiplying by 10, right? If I start with 10 cups and I multiply by 10, then I'm going to get 100 cups. So I'm going to multiply all of those values that I have in my first column by 10. So 5 times 10 is 50, 3 times 10 is 30, 2 times 10 is 20, and so on. Then it asks, for 200 cups, how much of each ingredient should I include? Well, to get from 100 to 200, I could either multiply my 100 cups by 2, and I'll get 200, or I can take 100 cups and add another 100 cups to get 200 cups. So I'm going to multiply because it seems faster to me. 50 times 2 is 100, 30 times 2 is 60, 20 times 2 is 40, and I can continue on with recipe number 2. Keep in mind that this column in the table asked me for a 200 cup recipe. I can check to make sure I did that by saying, okay, well, if there's 100 cups of orange juice, 60 cups of soda, and 40 cups of pineapple juice, that's a total of 200 cups. So I did it correctly. The next column asks for 50 cups, which I can find by either taking the 100 cups and dividing by 2, or taking the 10 cups and multiplying by 5. I think it's easier to divide by 2, so I'm going to do that. But it's up to you. 50 divided by 2 is 25. 30 divided by 2 is 15. 20 divided by 2 is 10, and so on. Then it asks us for 40 cups. This is takes a little creativity, right? So what I'm going to do is I'm going to take the 50 cups and I'm going to subtract the 10 cups. So in the 50 cup recipe, I need 25 cups of orange juice. But in the 10 cup recipe, I only need 5 cups of orange juice. So I'm going to subtract 25 minus 5 gives me 20 cups of orange juice. I'm going to continue like that. 15 minus 3 is 12. 10 minus 2 is 8. 20 minus 4 is 16. 10 minus 2 is 8. 20 minus 4 is 16. The very last column says 240 cups. And remember, this is the amount that we actually want to make for the recipe. So this is an important thing to get right. I can do this simply by combining the 200 cup column with the 40 cup column. So in my first row, 100 plus 20 is 120. 60 plus 12 is 72. 40 plus 8 is 48. Moving down, 80 plus 16 is 96. 40 plus 8 is 48. And 80 plus 16 again is 96. As long as I'm organized with my information, this problem should be fairly straightforward. So we're going to answer the 2 questions below. Which recipe has the most juice in it? Remember, the recipes are made up of juice and soda. So I want to use evidence from the recipe to support my answer. I'm going to work with the small numbers. So I'm going to look at the 10 cup recipe. And what it says is that for recipe number 1, I have 5 cups of orange juice and 2 cups of pineapple juice. So recipe 1 has 7 cups of juice, while recipe 2 has 4 cups of orange juice and 4 cups of pineapple juice. So recipe 2 has 8 cups of juice. So which recipe has most juice? Recipe number 2. And of course, you should justify your answer with a sentence explaining how you did that. Question number 2 says, which recipe has the most soda in it? I can go back and use the same strategy I used for problem number 1, or I can say, well, I already know that recipe number 1 has 7 cups of juice, so it must have 3 cups of soda. And I already know that recipe number 2 has 8 cups of juice, so it must have 2 cups of soda. So which recipe has the most soda? Recipe number 1. Finally, I want to make sure that you're completing your proof problems. There's 2 questions about the recipe that we've already talked about. One says which recipe will make the punch less carbonated, and carbonated is the gas bubbles in the soda. Again, use sentences to support your answer. And the second part, which recipe would you choose for 240 people, and why? Use numbers from the table to support your answer. So as long as you can explain your solutions, you shouldn't have a problem getting either of those questions correct.